Okay, today's topic is about meter bridge. So meter bridge is very similar to Wheatstone bridge. Both the bridges almost same. The only difference is with using meter bridge we can measure very small resistance. That's the only advantage. So first I will give a brief introduction of Wheatstone bridge. So this is the Wheatstone bridge connection. You have a voltage source. So the current flows and there is a galvanometer between these 2 points. When the bridge is balanced, that's the important condition. When the bridge is balanced, the galvanometer current is 0. Ig is equal to 0. Or this current from here to here, anyway it is going to be 0. So galvanometer current is 0. Therefore this will act as an open circuit. And finally we arrive at the result that P into S is equal to R into Q. That is P into S is equal to R into Q. So this condition is applicable only when the bridge is balanced. If I say bridge is balanced, it means that there is no current through the galvanometer. That's the meaning. Okay. That means PS is equal to P into S is equal to R into Q. That is P by Q is equal to R by S. Okay. This we will keep it as aside. Now we will concentrate on meter bridge. So meter bridge is same connection only. Only difference is PQ. PQ we have, and this R and S can be viewed as a single stretch of wire. Okay, it is good. Definitely it is going to have a resistance between this end and this end. Usually this wire is made up of manganese wire. Okay, so when you place a jockey at in between, you have certain length. That means a portion of the length can be viewed as a resistance, another remaining length can be viewed as another resistance. Okay, that means first we will check the circuit diagram. So voltage, here also voltage, then from voltage it reaches this point where P and R. So it reaches here, these are all conductor, then it goes to P. This side we have R. From here to here, this is jockey J, this is R. Okay, now P, then you have Q and goes to the negative. P, this is a conductor, then Q, then it goes to the negative of the supply. And of course we have a switch to switch on the circuit. Then coming this side, we have R and S. So positive, we have R up to this and remaining S. So this is R. This is not a lumped resistor. It is a wire, but still that wire will have a resistance. Okay. So we have the formula R is equal to rho L by A. Okay. That means the resistance of a conductor depends on specific resistance of that conductor or material, length of the conductor and the area of the cross section. That is, if you have a conductor like this resistance depends on the area of the cross section, length, and the specific resistance of that material, that is rho. So we know that. So now this is a manganese wire. Usually manganese wire is used, and it's a same material. Material has not been changed. That means a specific resistance is going to be same. Area of the cross section of the wire throughout the length, it is same. That means from here to here, which is R, the resistance is rho L1 by A. We have the formula rho L by A. From here to here, the length is L1. Therefore, rho L1 by A. And from here to here, the length is L2. So, rho L2 by A. Why this rho and A is same? Because same cross section. Therefore, area is same material. Therefore, specific resistance rho is also same. That means we know the formula R is equal to rho L by A. So if you substitute the value for all these things, you will get the value for R and the value for S, rho L2 by A. Now from this point between P and Q, the junction point of P and Q, you connect a galvanometer between R and S. That means you have a galvanometer, a high resistance to protect the galvanometer, and then jockey. You can slide this jockey. Okay, you can slide this jockey. You keep on sliding and see when the galvanometer current is 0. At that point you stop. That means the galvanometer current should be equal to 0. So galvanometer current is equal to 0 microamps. That means no current should flow. At that point you stop the jockey. Otherwise you just slide the jockey so that you see that the galvanometer current is 0 microamps. So this circuit and this circuit is same. Now the bridge is balanced. When we say bridge is balanced, the galvanometer current is 0 microamps. So the bridge is balanced. That means in the place of R we can substitute, rho L1 by A. In the place of S, the length is L2. Therefore, the resistance between these 2 points, rho L2 by A. So denominator term is S, rho L2 by A. Now if you carefully see, rho cancelled, A cancelled. So P by Q is equal to L1 by L2. Okay. Suppose if P is unknown, that means we don't know the value for P. A small wire, assume it is a small wire or anything, any resistance, lump resistance also, anything. Or very small resistance you want to measure. That means P is unknown. Now you know the values for L1, L2 and Q. Okay. So that means with these 3 values you can always find the value for unknown P. And similarly, if P is known, Q is not known. P, we know the value for P, we know the value for L1, L2 and Q value is not known. In that case also we can find the value of Q. And there is one point, since these are all conductors, copper conductors or sometimes stainless steel conductors, we have the terminal resistance, the end resistance, because this is made up of some material. So this will have end resistance. Suppose while doing meter bridge experiments, these resistance also will come into account. So we have to find accurately. For that, what we have to, suppose P is unknown. First you take the measurement by connecting P here. Okay, you take one reading. Then what you do is you interchange. Bring this Q this side and P that side. And once again the P is unknown, Q is known. Okay. So in that case what you will get, once again you will get one more value. You take the average for that, then that gives the correct value of the unknown resistance. So now you know the unknown resistance of a wire or a piece of conductor. Now you know the length of the conductor, the area of the cross section of the conductor also can be found. So area of the cross section of the wire, how we can find, with the help of screw gauge we can find the diameter of the wire. Therefore we can find the area. Area is equal to pi r square. So now we know the length, area, r. Therefore we can always find the value of specific resistance. That means if you connect a unknown conductor, a small piece of wire, you want to measure that measure the specific resistance of that material. So what to do now? You know all other values. You know the resistance, length and area of the cross section. The only unknown parameter is your specific resistance. So we can find very easily with the help of meter bridge. That's all about meter bridge. There is no difference between Wheatstone bridge and meter bridge. All are same. Only thing is mostly here we use lumped resistances, whereas here we will use negligible resistance, a wire with negligible resistance. So we can always find the value of very low resistance, a piece of wire. You want to find a resistance of the piece of wire. In that case you can go for meter bridge. But when the resistance is very high, unknown resistance very high, then you can always go for the option Wheatstone's bridge. So this is an important topic. So you must understand the basics of Wheatstone bridge and meter bridge. Both the results, final results, we arrive based on the condition what? The galvanometer current should be 0. That condition is said to be the bridge is balanced. Okay. Thank you very much.